storing grain in the southeast is a challenge. With insect pressures here in the southern states, even the best preventative measures will eventually fail. When that happens, fumigation becomes the only realistic way to maintain grain quality. As always, time and costs involved with fumigation must be weighed against the potential profits of continued storage. Grain fumigation is often economically feasible. However, fumigants are dangerous, so applicator safety and legal requirements must be considered. In addition, on-farm fumigations fail all too often because too little attention was paid to preparing an area for fumigation. This video is designed to help you conduct a safe and effective fumigation in on-farm grain bins and in bag commodities. It is not a substitute for reading the label that comes with the fumigant. The applicator's manual, which is part of the product label, contains detailed, important information. Labels on pesticides are a federal law. You must mix and apply that pesticide as the label states. You can only apply in areas named on the label. If you mix or apply it in a way inconsistent with the label, you are breaking a federal law. Aluminum phosphide fumigants are sold under a variety of trade names, including phostoxin, fumifos, phosfume, fumitoxin, gas toxin, and Decia fumex. All formulations of aluminum phosphide are restricted use pesticides. Therefore, you must be certified in your state in order to purchase or apply them. Most states have a fumigation category of certification for commercial applicators, those applicators that charge a fee for fumigation services. Most states allow farmers to use fumigants with a private applicator's license. It is your responsibility to make sure that you are aware of all label requirements and that you understand the safety hazards of working with aluminum phosphide. Your life or the life of a coworker or an innocent bystander may depend on it. Under the pesticide laws, it's required that pesticides be stored in a locked area that is separate from where humans or domestic animals live. It is especially important that aluminum phosphide fumigants be kept in a locked area to avoid accidents or theft. If any fumigant is stolen, you are required to report the theft to your local law enforcement authorities. Fumigants kill in the gaseous form, which is liberated from the solid aluminum phosphide. Aluminum phosphide reacts with water in the air to form highly toxic phosphine gas and aluminum hydroxide. Pure phosphine gas has no odor. A garlic smell can be detected when using phosphide fumigants. This comes from a separate breakdown of inert ingredients. Because it is a separate reaction, it cannot be used as an indicator of the actual concentration of phosphine gas. It is possible to have dangerous concentrations of phosphine gas without any warning smell. Formulations used most commonly on farms are in tablet or pellet form. Tablets are 5 times larger than pellets. However, phosphine gas is liberated faster from pellets than from tablets because of a larger surface area. The reaction also occurs faster at higher temperatures. Therefore, the fastest rate of gas generation would occur on a hot day using pellets, and the slowest on a cool day using tablets. The following sections will discuss fumigation safety, sealing techniques, dosage and exposure time considerations, placarding, aeration after the fumigation has been completed, and the use of a phosphine gas detector. Finally, we will discuss the preparation of a fumigation management plan. Safety during fumigation must be a top priority. It is important to treat aluminum phosphide fumigants with respect and to protect ourselves from accidental exposure. Fortunately, safety and effective application procedures go hand in hand. Fumigation can be a relatively safe operation if appropriate steps are taken. respiratory issues are the most critical. Fumigators must dedicate attention and resources to protecting their respiratory systems and the respiratory systems of their employees. Legal and practical issues surrounding respiratory protection include the threshold limit value. This is the legal limit above where respiratory protection must be in place. For phosphine gas, this is 0.3 parts per million in an 8-hour time-weighted average, or 1 part per million in a short-term 15-minute time-weighted average. Let's go to Dr. Wheeler Foshee, pesticide education specialist, for some more thoughts on pesticide safety.
I'd like to share with you the safety concerns and personal protective equipment that you'll use when applying aluminum phosphide. As you've already been told, aluminum phosphide combines with water and air to produce a very toxic gas, phosphine gas. And to say the least, this material is extremely dangerous. When you purchase aluminum phosphide and you look on the label here, you'll notice that there is a symbol here, and it's a skull and crossbone. And that skull and crossbone is determined by EPA through toxicological tests. And frankly, this just means that a little bit of this stuff will kill you. And so we need to be very cautious when we use aluminum phosphide tablets. And so let's talk about a few of the things that you need to know about. For instance, 0.3 part per million, that's 0.3 part per million, is a threshold limit. Now, a part per million is something that we talk about a lot in pesticides and in chemicals and so forth. But what is a part per million? Well, 1 part per million, to help you have perspective, is 1 inch in 16 miles, or 1 drop in 50 gallons of water, or 1 second in 12 days. So at 50 parts per million of phosphine gas, your life can be endangered. 50 parts per million. So that's 50 inches in 16 miles to help you gain some sort of perspective. Now let's talk about some of the protective equipment that you need to wear. You need to wear cotton gloves so that moisture does not condense there and you produce phosphine gas when handling the canisters here. So you need cotton gloves whenever you're handling the tablets, getting ready to apply it. Now, as far as a respirator goes, not every respirator will help you. Here is a full face mask type respirator, and this is very useful for putting out many agricultural chemicals, but it's absolutely useless when applying aluminum phosphide tablets. This one here I like to show, this is just a dust mask. And as I would tell you, this, about only good this would do is keep the dust off your face on your ride to the morgue if you wear one of these, because it'll absolutely give you no protection at all. What you must purchase and wear properly is an approved aluminum phosphide canister type respirator that has this olive green and purple stripe on it. Now this is very important because this particular canister has the right filtration in there to protect you.
If phosphine concentrations are below 15 parts per million, the gas mask and canister that Dr. Foshee showed you can be used. The gas mask can also be used in an emergency to escape from concentrations of up to 1,500 parts per million. Appropriate gas masks and canisters can be obtained from suppliers that serve the fumigation industry. On the farm, if you cannot monitor the concentration of phosphine gas in the air, and you have to enter the structure to apply the aluminum phosphide, you are required by law to wear a gas mask while you are inside the structure. A self-contained breathing apparatus must be available locally if it is not available at the fumigation site. Off the farm, if you do not know the concentration of aluminum phosphide, you are required to wear a self-contained breathing apparatus.
What I'd like to share with you next is just the label. You need to be sure and read this label and become familiar with the label. Just for instance, in here there's a note to the physician. I find it quite interesting to read part of this, kind of to drive the point home. One of the things it says here in the note to the physician is there is no specific antidote known for poisoning from phosphine gas. So if you're poisoned with this, you can't go to the hospital and get a shot of atropine or some other antidote and recover quickly. What it does tell the physician to do is to treat your symptoms. Like, for instance, it says in sufficient quantity, phosphine affects the liver, kidneys, lungs, nervous system, and circulatory system. And it causes lung edema. In other words, your lungs will fill up with fluid, and obviously a death can occur from high amounts of, or even low amounts in that effect of phosphine gas. So be sure to follow these precautions. Be very careful. If you follow these precautions, you should be able to use this material in a relatively safe manner.
When phosphine gas builds up to a concentration greater than 18,000 parts per million, it can burst into flame or explode. Therefore, aluminum phosphide products should not be stacked or piled up or allowed to come into contact with standing water. This causes a temperature increase, which increases the rate of gas production and the likelihood that a fire or explosion will occur. Phosphine gas can cause erosion of copper, brass, and other copper alloys. Phosphine gas will penetrate through bagged products and grains to completely fill an area. This property makes it a valuable pest control tool. However, it is very important to consider how phosphine gas will move during the fumigation process. Accidental leaks could harm workers and bystanders. If too much phosphine gas leaks out, some or most of the target pests can survive because gas concentrations never became high enough within the structure. Phosphine gas will move through small cracks and openings, which makes sealing leaks a challenge. It will eventually move through a large variety of materials such as concrete, cinder block, and plastic. Phosphine is just slightly heavier than air. It will sink to a certain degree. However, it is light enough that it will move with air movements. In steel bins, if your eaves are not sealed, it will move through the eaves. That's why it's so important to think about where you need to seal leaks and to characterize your fumigated area to know where you need to monitor to prevent accidental exposure to phosphine gas. Air monitoring devices determine the concentration of phosphine gas in the air. It is important to monitor worker exposure and environmental exposure during a fumigation. The gas detectors can also be used to determine the concentration of air inside the structure that is being fumigated. If the concentration is too low, more fumigant can be added. Information about air monitoring equipment is available from fumigant manufacturers and distributors. Safety equipment catalogs also provide valuable information and help in choosing the appropriate equipment. Two methods are commonly used to monitor the concentration of phosphine gas in the air. One method is using a handheld continuous exposure meter with a digital display. This meter may be able to monitor gases other than phosphine. A monitor that can detect oxygen, lower explosive limits, phosphine gas, and carbon monoxide could be very useful on the farm. In Alabama, 5 phosphine gas detectors have been purchased with wheat and feed grain checkoff funds. These are available for Alabama farmers to use when conducting a fumigation. For information on where to borrow these detectors, contact the nearest office of the Alabama Cooperative Extension System. Similar programs may be available in other southern states. The second method consists of using tubes that change color to indicate the gas concentration. These tubes are used with a special pump that draws a sample of air through the tubes. The further the color goes along the tube, the higher the gas concentration. Different kinds of tubes are used to indicate different gas concentration, so each type of gas requires a different tube. Low-level detecting tubes for concentrations from 0.15 to 5 parts per million are suitable for most uses. Extension hoses are available so that inside air can be sampled from the outside. The Occupational Safety and Health Administration classifies most structures in which commodities are stored as permit-required confined spaces. A confined space is any enclosed space that has limited means of entry or exit and that is not designed for continuous occupation. If the atmosphere is potentially hazardous, or if there is a chance of a person becoming engulfed by solids or liquids, the confined space is classified as a permit-required confined space. This means that a safety procedure for the use of that space must be developed to make everyone aware of potential hazards and to define the safety precautions that must be taken before anyone can enter the space. On-farm grain bins and on-farm stored commodities are exempt from the confined space permit requirements. However, that does not make them any less dangerous. During a fumigation procedure, observe the following safety rules in addition to the rules specifically related to fumigation. Wear a safety belt or harness equipped with a properly fastened lifeline if the commodity is more than waist high in the storage structure. The surfaces of stored commodities can be unstable, causing the commodity to collapse and workers to be engulfed or suffocated by it. Suffocations have occurred in gravity and auger wagons and trucks, as well as in grain bins and silos. Wearing a safety harness will also prevent injury due to falling from a bin or silo. Always have someone outside the storage structure in case of an emergency. Never attempt this kind of work alone. If a storage structure has a ventilating fan, turn on the fan to thoroughly ventilate the structure before anyone enters. Grain dust can build up potentially explosive concentrations within a bin, and spoiling grain can give off enough carbon dioxide to reduce oxygen and cause suffocation. Do not allow anyone inside a confined space storage structure while the commodity is being added or removed. Accidents often occur when someone tries to break up crusted material while the commodity is being drawn out of the structure. From the outside of the bin, use a pole or weighted line to loosen crusted material inside the bin. To kill the bugs, you have to have a certain concentration of gas. If you do not have that concentration of gas with the right amount of time, you've wasted your time and your money. Seal all potential gaps to increase the gas concentration in the bin. The length of time a lethal concentration of phosphine gas is held is more important than the maximum concentration. It often means the difference between success and failure of an on-farm fumigation. Phosphine fumigation needs at least 200 parts per million for a period of time to have a good chance of success. Levels as low as 100 parts per million will result in success if it can be held for an extended period of time. Generally speaking, lethal concentrations of phosphine gas must be maintained for 2 to 3 days in order to get a good kill throughout the grain mass. A fumigant must kill all life stages. Research has shown that the pupae and egg stages of some species are much more difficult to kill than the adult or the larvae. A poor fumigation may show good kill of adults, but yet within a few days, new adults can appear. Sealing potential leaks is critical to make sure the fumigation is safe and effective. Even small holes in the structure can result in significant leakage and disappointing results. Try to build and maintain grain bins that can be easily sealed. Every step taken to seal leaks helps. Gas loss can occur at many places in the metal grain bin. These bins were not designed to be sealed tightly. Escape points include eave and roof junctures, aeration blowers in the bottom, and air ducts and elbow vents on top. Other areas include spouts and auger pits. The best time to seal cracks and holes in bins is before the grain is loaded. Standing in an empty bin with the door closed, one can quickly see spots of daylight where gas could escape. Use high-quality sealing materials. Effective sealing can usually be done with aerosol foam sealants, at least 4 mil polyethylene plastic, and high-quality duct tape, aerosol adhesives, and caulk. Aeration fans need to be sealed off. The best way to do this is to disconnect the fan and take it off completely. Otherwise, cover the fan with plastic and duct tape and seal any remaining cracks and bolt holes with foam sealant. It is often possible to place a plastic tarp over the top of the grain to keep the gas from rising and escaping through roof and eave vents. The speed of the reaction where aluminum phosphide breaks down into phosphine gas depends upon the moisture at which the raw product is exposed and the temperature at which it's exposed. Gas is released faster at warmer temperatures. As you can see, fumigation is not recommended when grain temperatures are below 40 degrees Fahrenheit. The exposure tables in the applicator's manual are based on an 11.9% moisture content of grain. The drier the commodity, the slower the release. If the commodity mass is sealed properly, gas may stay in there indefinitely, and therefore it is very important during the actual application and post-application to monitor that mass with gas detection equipment. The applicator manual has suggestions on how much fumigant you need. Do not use more than the maximum allowable dosage of 725 pellets or 145 tablets per 1,000 cubic feet. That translates to 900 pellets or 180 tablets per 1,000 bushels. Use the lower range for tightly sealed structures. The higher range dosages are needed where the fumigant cannot be applied uniformly, such as with grain stored in tall silos. Higher dosages are usually recommended under cooler, drier conditions or where exposure periods are relatively short. When calculating the amount of fumigant to use, you have to consider the entire volume of the structure. For example, in this grain bin, you would have to calculate the volume of the air in the top of the bin and the peaked roof as well as the volume of the grain. If a poly tarp is placed over the surface of the grain to keep the fumigant in, then you only need to calculate the volume of the grain. Alabama Cooperative Extension publication ANR 1154 has diagrams and formulas that should be useful in calculating the volume of the structure being fumigated. When you read the aluminum phosphide applicator's manual, you will see there is a section on the fumigation management plan. This written plan is a legal requirement. It is meant to help organize the fumigation process and make sure all safety, efficacy, and legal considerations are addressed. Once you have prepared a plan, it can be modified as needed and reused at the same site. You will need to keep the plan on file for 2 years after the fumigation. The applicator's manual has a checklist of the kind of information that should be included in the plan. Each fumigation plan will be different. A plan developed for isolated grain bins where there is no likely exposure to humans will be different from a plan for a grain bin located within a town or nearby inhabited structures. This plan, designed for grain bins located near the farm office, took about half an hour to prepare after the applicator has read the applicator's manual. In the plan, you need to document who, what, when, where, how, and why. For example, who should be told about the fumigation because they might be accidentally exposed to phosphine gas during the fumigation, or who should be notified in case of an emergency. Include the phone numbers of the nearest fire department, police department, hospital, and your physician. Also, who will conduct the fumigation. 2 people need to be present during the application process. They need to be qualified to conduct the fumigation. What commodity will be fumigated? What type of structure will be fumigated? A grain bin? If so, what size? A stack of bagged seed? When will you begin the fumigation, and when will you end the fumigation? When will it be safe to use the commodity? Describe the characteristics of the site, including a sketch. On the sketch, include the location of the nearest phone, emergency utility cutoffs, and any potential hazards. Indicate places where people might be accidentally exposed to phosphine gas, such as nearby buildings. Think about where phosphine gas can escape and where you need to seal potential leaks. Where will you post warning placards?
During fumigation, site characteristic is a critical component and absolutely mandatory for a successful and safe fumigation. For example, this facility, if we wanted to fumigate this bin, there's 3 particular issues safety-wise that are involved. Number one, the fumigant would follow the leg up in there and distribute down into the other bins and this feed mill. So if we had workers or ourselves in there, there's likely a potential exposure to the fumigant itself. A second issue is how close is the area we're fumigating to the proximity-wise to where our workers or ourselves are going to be. On this particular one, we likely have fumigant coming through the seams and potentially entering in there, and where legally and practically it's a good idea to monitor that to make sure we don't have any exposure. A third area with this particular facility, there's a conveyor that runs down the middle of it that's connected to the bins and the feed shed. You would have fumigant moving in there, following the conveyor, and potentially exposing workers. In this particular facility, chances are we would have to close this down for safety reasons. And it's very important to minimize exposure to ourselves and our workers.
How will the structure be sealed? How will accidental exposure be prevented? How will you apply the aluminum phosphide pellets or tablets? How will you monitor gas concentrations? How will you aerate the structure? Why was the fumigation necessary? Give a copy of the finished plan to the required emergency agencies. Make sure that the applicators have a copy of the plan and a copy of the label, including the applicator's manual, at the fumigation site. Finally, it is time to begin to fumigate. Do not try to fumigate by yourself. The label says you must have at least 2 trained people present in order to fumigate. A certified applicator must be physically present, responsible for, and maintain visual and/or voice contact with other workers. If the structure has to be entered to apply the fumigant, it is best to have at least 2 people inside and 1 person outside. If you plan to tarp the surface of the grain, have the tarp on top of the grain ahead of time and carefully fold it back so you can apply the fumigant tablets. Make sure that you have a rope attached to the tarp that leads to the top of the grain bin, so the tarp can be pulled back from outside the grain bin after fumigation. Open the fumigant containers outside the structure to be fumigated. Point the container away from your face and body, then slowly loosen, then remove the cap. Once the initial buildup of phosphine gas has been vented, you can replace the cap if needed and proceed with the application. Turn on your digital gas detector. Keep your gas detector in your breathing zone. Apply the fumigant tablets or pellets. You can scatter the pellets across the surface of the grain or use a PVC pipe about 1 1/4 to 2 inches in diameter and 5 to 7 feet long to probe the fumigant into the grain. Use 20 to 50 tablets or 100 to 250 pellets per probe. Probing the grain takes time and exposes you to potentially dangerous levels of phosphine gas. If the bin is well sealed, this step is unnecessary. If you are scattering the fumigant on the surface, take care not to pile large piles of fumigant where explosive concentration of gas can occur. Unfold the tarp if you are using one and then get out of the bin. If the bin has an aeration fan, you can put up to 25% of the fumigant in the aeration duct. Make sure the duct is dry before adding the fumigant. Consider putting the material on a cardboard box cover or something similar that keeps the fumigant away from any hidden standing water. Finish sealing the aeration duct. Placards must indicate who did the fumigation, the materials used, when the fumigant was introduced, and when re-entry can occur. Put these on every entry into the bin, side doors, and next to the ladder. The applicator manual explains exactly what must be on the placard. After the fumigant has been introduced, monitor the air around the bin to see if there are any leaks. If you find leaks, seal them using more plastic or expanding foam. If gas levels inadvertently exceed permissible levels in nearby work areas, remove all workers from that area. Check gas levels as often as possible during the fumigation, as noted in your fumigation plan. Monitor gas levels outside the structure as well. To monitor gas inside the structure, you can put monitoring ports, such as this hose, that lead from the inside of the structure, yet can be unsealed and attached to an air monitoring device. Keep a written record of all gas concentrations. If the gas concentrations are too low, more fumigant can be added through specially designed ports, providing exposure to the applicators does not exceed permissible levels. Consider a lockout device to keep people away from the area being fumigated. The end of the fumigation is just as important as planning in the beginning. After the recommended exposure time, you cannot assume that all the phosphine gas will be gone. On the contrary, the better job that is done sealing, the higher the gas concentration that will remain. Your fumigation plan will include a plan on how to get the fumigant out of the area. In a grain bin, this usually involves unsealing the top of the bin and unsealing the aeration fan. Run the fans until the phosphine gas is below 0.3 parts per million. Once the concentration of phosphine is less than 0.3 parts per million, you can remove the placards and re-enter the structure. If the grain is to be used as animal feed, the concentration of the gas must be lower than 0.1 part per million. If a gas detector is not available, run the aeration fans for at least 48 hours to make sure the gas has dissipated. Remove lids and expose empty flasks to the air until all residue is reacted. Triple rinse empty flasks and stoppers with water. Empty containers can then be recycled and reconditioned or punctured and disposed of in a sanitary landfill. Phosphine gas has excellent penetrating capabilities, but its ability to evenly diffuse through a structure has limits. Some factors that interfere with even distribution are leaks that release the fumigant from the structure as fast as it diffuses within the structure, insufficient dosage for the volume being fumigated, a tightly packed commodity with very little airspace, such as a warehouse full of bagged or other packaged material, or a farm bin with too many fine particles and dust mixed with the grain. Low temperatures resulting in the slow release of phosphine. Large volume structures with no means of application other than shallow probing or surface application. When any of these conditions exist, insects may be killed in one section of the enclosure and not in another. One way to deal with the problem of uneven distribution is to use a closed-loop fumigation system, which improves the distribution of phosphine gas. It involves the use of a tubing system and a blower to continuously recirculate the phosphine gas during the fumigation period. The system can be designed in a number of ways, but for most situations using 4 to 6 inch diameter PVC pipe and flexible solid drain tile is an inexpensive way to move gas from one point to another along the outside of the structure. The system should be designed to draw the gas from the bottom of the bin, through the commodity, and up to the top of the bin. A blower of sufficient size to move air should be placed at a convenient point in the system. Usually a 1/4 to 1 horsepower motor is adequate. Proper sealing of the structure is even more critical with closed-loop fumigation, since recirculation may speed up the escape of gas. Make sure all joints between sections of tubing and all entry and exit points are well sealed with duct tape, caulking, or other means. Place all tubing away from high traffic areas and protect it to prevent accidental damage. Test the system for leaks before applying aluminum phosphide. Closed-loop fumigation systems are usually not necessary in small, less than 5,000 bushel tightly sealed bins. Closed-loop systems do eliminate the need for labor-intensive probing operations or for moving grain from a full bin to an empty bin for the sole purpose of fumigation. Closed-loop systems can be safer than probing operations because the fumigant can be applied to the top of the grain so that the workers are not required to be inside the structure as long. Gas recirculation can also reduce the time needed to conduct a fumigation because it hastens the distribution of the gas. The increased fumigant efficiency and lower dosages will usually pay for the startup costs in 1 to 4 years. One of the easiest and least expensive ways to provide a relatively gas-tight enclosure is by using plastic sheeting or tarps to enclose the commodity. The volume of these enclosures may vary widely from a few cubic feet, for example, a tarp placed over a small stack of bagged commodity, to a 600,000 bushel capacity plastic bunker. Cover the bulk or packaged commodity with polyethylene sheeting. Tape sheets together if necessary. Use 4 mil thick polyethylene plastic for most applications. 2 mil plastic may be adequate for small jobs in sheltered areas. Do not forget about the floor under the commodity. If it is porous like wood, move the commodity onto 4 mil plastic and then cover it. Seal the plastic covering to the floor by taping, weighing down the ends of the plastic with soil or sand, or use some other suitable means of sealing. Reinforce the polyethylene covering with tape to reduce the risk of tearing, especially around corners and other stress points. Fumigant packages designed to contain fumigant residues, such as pre-packed strips or sachets, are recommended for treating bagged commodities and processed foods. But tablets and pellets on trays or sheets of thick paper can also be used. Add the fumigant through slits in the polyethylene covering. Tape the slits in the covering to prevent gas leakage once the dose has been applied. Probing or other means of dosing can be used. Do not apply large amounts of phosphine fumigant at any one point. Place the fumigant below the surface of the commodity if condensation is likely to form beneath the polyethylene. Check to make sure that the tarp or plastic sheeting allows the solid fumigant free contact to moist air and allows the phosphine gas to diffuse through the entire storage area. Commodities under fumigations cannot be moved over public roads. A commodity could be fumigated in a sealed truck trailer but would have to be aerated and deplacarded before moving onto a public road. Do not accept a truckload of grain that indicates that it has been fumigated in transit. However, rail cars and ships can be fumigated in transit as long as all rules and regulations are followed. Only trained personnel are allowed to aerate, open, and deplacard rail cars and ships. We hope this video has provided you some tools for safe and practical application of fumigants. More information is available in other Alabama Extension publications, such as ANR 1154, available at your Alabama Cooperative Extension office or at www.aces.edu.